Let us discuss this example. So in this example, we have a Cauchy sequence xn, okay, and that sequence has a subsequence xnk. Subsequence already we have seen, so you are familiar with that. In subsequence, what we do, we collect few terms from a main sequence and we form a new sequence that is called subsequence. What we have to prove? We have to prove that d of xn xnk, d of xn xnk, that means distance between xn and xnk, which is a real number, it converges to 0. This thing we have to prove. Okay, so see, let us prove this thing. So I have already taken epsilon greater than 0 be given. Okay, I am going to consider mod d of xn xnk minus 0. We are getting this point. We have to prove that this sequence converges to 0 in R, okay, with usual metric. In R, we have to prove in usual metric. So this usual metric is mod. So that's why I taken mod. We have to prove that it is less than epsilon. Then we can say yes, d of xn xnk converges to 0. Let us simplify it first. If you subtract 0, we will have same d of xn xnk. But you know that distance, d means distance, which cannot be negative. So there is no need of mod. We will have a same. So this is d of xn xnk. So we have reached up to this step. I will call it as 1. After that, let us use the given information. What we have xn is a Cauchy sequence. We have xn is Cauchy. So therefore, we can use definition of Cauchy sequence. What can we write? So therefore, for above epsilon greater than 0, epsilon already we have taken here, no? There exists n belongs to set of natural number such that d of xn xm less than epsilon for all nm greater than or equal to capital N. Okay, using definition of Cauchy sequence, we could write it. But for subsequence xnk, you know that nk is always greater than or equal to k. Getting? So again, using definition of this one, I will write there. Then from 2, tell me what can I write? I am writing it for subsequence. D of xnk is less than epsilon for all nk greater than or equal to capital N. Okay, using 2 we could write it. So this is inequality number 3 or statement number 3. If I combine 1 and 3, tell me what will I get? I will write from 1 and 3. See this one, mod d of xn xnk minus 0. We have proved that this is equal to d of xn xnk, and we have proved that it is less than epsilon. So if I combine, we can directly write this is less than epsilon for all nk greater than or equal to capital N. Get it? So therefore we can write, therefore d of xn xnk converges to 0 in R with usual metric. So RU I will mention. So in this way we proved. Make a screenshot of it, then we'll stop. Thank you. Bye bye.